So example number 1, a motorcycle initially at rest, accelerated uniformly at 3.5 meters per second squared north with a displacement of 65.5. What is the final velocity of the motorcycle in meters per second and kilometers per hour? So if the initial velocity was 0 because the object is at rest, the acceleration is 3.5 meters per second squared, and the displacement is 65.5 meters. Then, of course, the unknown is the final velocity. So final velocity is unknown, and in this case, since there's no mention of t, we use the equation that doesn't have t in it. Vf squared is equal to vi squared plus 2ad. In this case, the initial velocity is 0 plus 2 times 3.5 times 65.5. And of course, what we end up with is a solution that is the square of the final velocity. And that is 458.5 meters squared per second squared. And of course, to get Vf by itself, we take the square root of that. And of course, the square root of that is 21.41, or 21.4 meters per second. Now the last step is, of course, when you want to take meters per second and convert to kilometers per hour, the long way, I'll show you once, Vf is equal to 21.4 meters per second. If we want to convert to kilometers per hour, we would multiply by 1 kilometer for every 1,000 meters. And of course, there are 3,600 seconds in an hour, 60 seconds and 60 minutes. So 3,600 seconds per hour. And of course, the seconds cancel the seconds, the meters cancel the meters, and we're left with kilometers per hour. And it's the same as taking 21.4 and multiplying by 3.6. So if we take that, multiply by 3.6, we get 77.1 kilometers per hour. So our solution is 21.4 meters per second, or 77.1 kilometers per hour. And they asked for the velocity. Well, they don't actually, oh, they do. They actually give us the velocity in terms of the acceleration is, they give us a displacement of 65.5 meters north, and therefore we can say that the final velocity must be also north and north in kilometers per hour as well. All right, so make sure if they ask for the velocity, you take a look and make sure you can answer both the magnitude, 21.4, 77.1, and the direction.